car driving off of a plank. Let's look at yet another example. A 20 kilogram, 10 meter long plank. Now we have a plank with a mass. Looks like it's evenly distributed, so I know that's going to be acting at the center of mass for that 10 meter long plank. So at the 5 spot right here, that's where my weight force is acting. Rests on the edge of a cliff with 4.5 meters of its length over the edge. A toy car of mass 4 kilograms ventures out onto the plank, driving past the edge of the cliff. At what point X past the edge of the cliff will the plank tip? So another new little twist here. Now we're not looking for the mass of an object. This time instead we're looking for the distance from the pivot point that we would be looking at this. Alright, so at first, when I first look at this picture and I first read the problem, and I don't know that I'm in the torque chapter, because on the actual exam you're not going to know what problem you're dealing with or how to solve it. So looking at this, I see that there's some kind of height here, obviously. So I know there's gravitational potential energy here, because whenever I see a height, I think gravitational potential energy. Can I use conservation of energy here in any way? No. No. Can I use work here? No. Instead, it's not obvious. This question is tricky because it's not obvious that this is a rotational problem. So instead, in your brain, you have to kind of think of this being a cartoon. And if you hit that play button, what's going to happen? Well, these two things aren't attached to each other. So if you have a force going down here, it's going to rotate about this point. So just looking at the picture and thinking what's going to happen, that would be a good strategy to help determine that this is a rotation problem. If it's a rotation problem, now we're talking about masses and distances. Okay, now I can deal with torque because I'm familiar with those. So the other hint would be if you see a plank, that's my go-to torque. Plank, torque. If it's just not obvious that it's going to be rotating, I would say, when you see that word plank, think about torque as a possibility for solving the problem. Starting with the three forces acting on the plank. We have the plank's own weight acting at the center of mass, so at the 5 spot right here. Then we have the car's weight acting at point X, right here. There's also a normal force on the plank which acts at the axis, up here. That normal force acting at the axis, is that generating any torque? There's the forces. Let's see, the green force is the weight force of the plank. It acts in the center of the plank, which was 0.5. It is, 0.5 meters to the left of the axis. 5 meters from the end, but do we care about the distance from the end? No. We have to think in terms of how far are we from the axis. That's what that little r is in the equation. That lever arm, that radius of action. That's your distance from your pivot point, which in this case, if this center of mass is at 5 meters, and we know this is 4.5 meters, so this is our axis of rotation, then this is going to be the distance here, 0.5 meters. This force will produce counterclockwise torque. And then we have the blue weight force acting a distance x from the axis. This force is going to produce a clockwise torque. Ignore everything else, it's going to rotate like this. If we take the car off and we have just the weight, it's going to rotate counterclockwise. But there's this table in the way, so it's not going to rotate if there was no car there. Right before the plank tips, the torque of the plank's weight balances the torque of the car's weight. So we will set the two torques equal to each other. Anticlockwise equals clockwise. We have 0.5 times 20 times 10, and then x times 4 times 10. Again, no sine theta because they're at 90 degrees. We get the distance of 2.5 meters from the pivot point. When we're dealing with rotational stuff, we're looking for the distance from the axis of rotation. So the car is going to rotate if the car travels more than 2.5 meters from the edge of the cliff. Remember, this is not the cliff at the very end. The cliff is the pivot point. So 2.5 meters from the pivot point, from the axis of rotation. This is how we can use torque to predict what's going to happen. And this will come in handy for you. Just don't forget about it. Use it. Even outside of physics.